Structural steel did not commence its life looking like a shiny metal. Rather, it started off as a rock called iron ore. Iron ore contains the element iron combined with oxygen together with impurities such as silicon compounds. In a blast furnace at 2000 degrees centigrade, we combine the iron ore with high-grade coal called coke and limestone. The coke extracts the oxygen, producing carbon monoxide, and in the process the carbon fuses with the iron, so the resultant pig iron may have up to 4% carbon. The limestone attracts the impurities, forming slag that floats at the top and is tapped off. When it's allowed to solidify, it is then ground into a fine powder and added to cement in the production of concrete. Pig iron or cast iron may be used to make castings like this sample here. However, to make structural steel, the excess carbon needs to be burnt off in an electric furnace and other alloying elements added. I have in front of me a variety of structural steel sections. Some sections are called universal, having flanges of uniform thickness, whereas others have tapered flanges. The universal column or UC has a top and a bottom flange connected by a web, and in the case of the UC, its width is equal to its depth. On the other hand, the tapered flange column or TFC has flanges that are thicker where they meet the web and taper towards the edges. The universal beam or UB also has flanges of constant thickness, however the plates are thinner than the corresponding UC and it is deeper compared to its width. The next section here is called a tapered flange beam or TFB, which once again has flanges that are thicker where they meet the web, tapering out to the edges. The parallel flange channel or PFC has a C shape with flanges of equal thickness. The next section here is called an angle. That may be an equal angle or an unequal angle. All these open sections are hot rolled because they're rolled into shape from hot ingots. The following closed section are formed by folding plate and welding longitudinally. Here we have a rectangular hollow section or RHS that has an end cap, a square hollow section or SHS, and a circular hollow section or CHS that has been laser cut. This following section is called a C-purlin or girt and is made up by a completely different process. It is cold formed because the section is manufactured by pressing and folding steel while still in the cold state. A central issue with structural steel is the need to protect it from corrosion, that is to prevent it from rusting. Rust can be seen developing at the base of this universal beam offcut. Now, in order to prevent it from corroding, we have various options at our disposal. One is to dip the steel into a bath of molten zinc, a process called hot dip galvanizing, and this C-purlin that we see here has been hot dip galvanized. If we intend to apply a paint system instead, we have to first remove the mill scale that develops in the steel mill. As you can see from here, the mill scale has a typical black colour and shouldn't be confused with rust. The quality of corrosion protection will depend on the percentage of this mill scale that we remove. So for example, class 3 grit blasting will provide a very clean surface free of most of the mill scale and allow a better bond with the primer. If on the other hand the steel section is to be used in an interior environment, class 1 grit blasting such as this may be sufficient, leaving a greater portion of mill scale behind. The second stage is to apply a zinc-rich primer like the coating seen on this section. This will be followed by a second top coat that is compatible with the primer. The SHS that we see here has had the top coat applied and has now had its paint system completed.